Mystery package time. Well, so much for the mystery if you read the title or saw the thumbnail. So, I'm going to unpack this thing and take a look. Okay, so this is what you get for your $9. Looks like a little control panel and electronics for what appears to be a practice amplifier for guitar use. Or I guess you could use it for other things as well. It doesn't have any effects channels. It's all just clean signal. Claims to put out 5 watts into 4 ohms, and we'll check that out. It's not going to be real powerful. It runs on only 9 volts DC. Looks like a power LED there, on-off switch, external speaker line out. I guess this switches the internal speaker on and off, or this external speaker, I don't know. We'll figure that out. Headphones, little cable tester. We have a treble bass and volume. I like how they indicate the levels with coin values there, penny, nickel, dime. And auxiliary input in the pedal or guitar input. All these jacks along the bottom are 9-volt outputs, so you can connect an effects pedal so you don't have to run it on batteries. So that might be handy. So in the back here, I have a couple op amps. Ubiquitous 4558, that's used in a lot of electronics. And we have a couple TDA 2003s. Haven't seen them in a while. Those appear to be authentic as well. I can tell by the case and the way that, see how the legs, the pins are thicker as they enter the package there? Those look authentic to me. Now this was made back in 2011, and that's when those chips were still available. So yeah, this, if you've been looking for that IC, it's a very good IC. Yeah, this could be the ticket. You know, for $9, you can get a couple chips if you want to harvest those off the board. And appears to be in a bridged configuration. There's 2 chips, and you know, this is not stereo, so it might be able to do 5 watts, an honest 5 watts, but we'll check all that out. Alright, I guess the next thing to do is power it up and put a signal through it. Okay, got it hooked up to the power supply. I'm using the connector in the back. 9 volts. Sitting idle here, it's drawing almost 100 milliamps. So yeah, it's quite a bit. If you're going to use it on batteries, you probably want to use D cells, or something that has more capacity, because that would draw smaller batteries down pretty quick, like AA's. Just sitting idles. Quite a bit of current, really. Another thing you have to watch out for is if you do use a barrel type jack, make sure the center or the inside is negative. This is kind of opposite of what's common. So you got to watch out for that. And I got a signal connected to the auxiliary. Had to turn off the AC. That's why I don't like to use classical, because it gets real quiet and there's no bass. Oh, whatever. But I noticed one thing here. This control actually all of these, do not have any effect over the line in, or what they're calling auxiliary. So if you do use this, you'll have to use the volume control on the device that you plug in, because these don't affect the auxiliary in. It'd be nice if they had a master volume control, but they don't in this case. So let me find a connector for this and put a signal in and see what it sounds like that way. Well, I'm not a guitar player, so I'm just going to put a signal into this jack here. Okay, so everything seems to work okay. Bass and treble. This is kind of reverse from what you normally see. Normally bass is on the left, but oh well. You can hear the wireless router making that thumping noise when I turn it up. That's not a problem with this thing. Okay, so let's hook it up to the scope and connect it to the resistive load there and do some power tests and some other measurements. See what this thing can do. Okay, we're connected to the 4 ohm load. 1 kilohertz signal. There's clipping. No oscillations or anything. But anyway, let's dial out the clipping. Get some waveforms on the screen. Looks like 4.06 volts squared divided by 4. 4.1 watts. Well, I was hoping we could get to 5, but 4 watts it is into 4 ohm loads. Okay, I'm running a 10 hertz to 100 hertz sweep. And ooh, that's pretty low signal. 0 dB I set at this graticule and this graticule here. We're at 50 hertz. I have the tone control set flat. Wow, does this thing have a major roll off. It is for guitar, of course, so you know they're probably rolling off the bass purposely. We're almost at 100 hertz and it's not quite there yet. Here's 20 to 20 kilohertz. Wow, look at that thing. Here's a restart of it. See, it drops and then it goes back up. They have two filters probably affecting each other. But the 0 dB point is way off. We're at 7 kilohertz now. It must be the treble. See if I drop this treble. It has a large effect. But I'll set it back to 0. Now it went into clipping, it looks like. Let me try that through the auxiliary input, see what it does. Okay, this is 10 hertz to 100. Yeah, it's starting out slow again. Real low. Looks like a pretty heavy second order harmonic, too. Okay, we're almost at 100. Well, recycled, but yeah, we were way off. 20 to 20 kilohertz sweep, and we're already at 1 kilohertz, so it's going to be pretty flat there. except at the low end. Even the auxiliary channel suffers that deep roll-off at lower bass frequencies. Okay, we're almost there. It's pretty flat, except, like I say, down under probably around 200, 300 kilohertz, hertz, it just rolls off severely. Pretty flat. There's no bass response. Okay, so now we're looking at distortion through the auxiliary input. And it's, to me, it's surprisingly high for using op amps and chip amps. You know, this here is the fundamental. This is the 1%, 4.5 kilohertz pilot signal. And you got a second order here that's like, I don't know, 60 or 70% of that. In other words, about 0.7%. And then there's the fourth and a couple of nodes out here. A little higher than I expected, but really for guitar use, nobody's going to care. Here's through the guitar input, and it's about the same, really. Well, after analyzing the circuit a little bit, I determined a few capacitors that you can replace to improve the low-end frequency response if you wanted to use this thing for something other than a guitar amplifier. Well, this capacitor right here, C16, this looks like a little ceramic capacitor. I would replace that with a 2.2 microfarad film cap. Same with C15, it looks like there. Replace that with a 2.2 microfarad cap. And this cap right here, E6, replace that with a 47 microfarad cap. And that will get your bass performance up much better. At 20 hertz, it'll bring it to within 3 dB of being flat. You know, to get it all the way, I'd have to analyze the circuit more and, you know, replace more caps. But for this, 3 dB is plenty good. So as a demonstration, here's what happens when you replace C15, which is the interstage coupling cap. Couples the preamp part of the circuit to the power amp part. And let's see here, I'll just touch that on there. You can see it brings it up somewhat. But if you replace those others, it would bring it up to somewhere around minus 3 dB of being flat. With the volume turned up and the tone set flat, the gain from the pedal/guitar input is around 52 dB, and the impedance is very high. It's north of 100K, so it should be good for guitar use. Some people mentioned running this at 12 volts instead of 9 volts for more power. Well, you should be able to do that. The capacitor values have enough voltage, and the chips and everything can handle that. However, that heat sink, it's a little on the small side for a bridge amp to handle that. You know, you'd be cooking these chips trying to do that. Might be able to get away with it with an 8 ohm load, but yeah, the heat sink's a little on the small side. Would I use this thing for anything? I don't know. I really don't have a use for it. I might just harvest those chips off of it because they are obsolete and you can't find authentic ones, and those are authentic. So if you've been wanting those TDA 2003s, there you go. There's a source for them right here. So there you have it, a review of the FootNote guitar amplifier board. I think it would work fine for guitar use. Maybe a little practice amp. Like I said, I'm not a guitar player, but I would think the frequency response could be a little better. I would recommend doing those modifications. And you'd really want to do those modifications if you're going to use it for another purpose, like, you know, amplifying music or something like that from a music player, because the low frequency response is really poor on this as it stands. And that'll do it for this one. Thanks for watching.